Hey, so we're starting now. We're going to take a look at this section 1.2 in statistics, where we're looking at our quantitative variables for the very first time. How do we chart them? How do they look? Well, we'll see. So we're going to take a look here, and with this, we've got a question. How many pairs of shoes do you own? Mark your choice on the board. Females use a red marker, males use a green marker. Well, we did this during one of my classes, and we came up with the following over here. We had, this data right here. Two pairs of shoes, 2 males own 2 pairs of shoes, no females, for a total of 2 people. And that kind of goes down the line. None of this has been added. It's pretty raw data. So we're going to have to make some sense of it using some other statistical tools. Now we can look at question 2 now. Is the number of pairs of shoes quantitative or categorical? And when I think about whether or not it's quantitative or categorical, when I go and ask a person or something, and I say, well, how many pairs of shoes do you own? Will you be answered with a yes or no, or well, I own green shoes, or will you be answered with a number? And the fact that you're being answered with a number, I own 4 pairs of shoes, means that this is a quantitative variable. So quantitative means that the responses are going to be a number, and everyone's going to have a number that is, I don't know if saying unique to them is the correct way to phrase this, but everyone has their number. Now, the next thing it says we're supposed to do is to go to Statlet.com and enter the data. You're going to make a dot plot, a stem plot, a histogram, and you're going to sketch it below. So before we go to do that, I'd like to mention to you that creating a stat plot, creating a stem plot, creating a histogram without Statlet.com is a central part of AP Statistics. So you should know how to do all of these without the use of additional software. They are super easy to do. As soon as you see them, you'll know how to make them, most likely. And the only place where people consistently do something wrong is when they forget to label their graph, label their x-axis, label their y-axis, fail to put titles for each axis, a title for the graph, and then perhaps units for each of the axes. So make sure you're putting all of that stuff in there. What did I say? Titles, uniform scales on both axes, labels and units for all the axes. If you do those 3 things, then you should be coming out ahead here. So let's go on to Statlet.com. Here's Statlet.com, and we went to one quantitative variable, single group. I have no doubt that we'll be going to multiple groups later on in the exercise. So we're going to enter in a few things. The first one is variable name, number of pairs of shoes. We're just going to input this as raw data. So when you input this as raw data, you're just going to put every number in the total section. Well, not even that. The first person had this one right here. We have 2 people with 2 pairs of shoes, so 2 and a 2. We had 1 person with 3 pairs of shoes. We had 2 people with 4 pairs of shoes, 2 people with 5 pairs of shoes. So you would imagine each person is individually typing in how many pairs of shoes they have. How many people have 6 pairs of shoes? 3. And then you're going to go on down the line with all of the observations. So there we go. We've gone and we have added every person put in how many pairs of shoes they own. You'll notice some repeats here, 11, 11, 11, 11. That means 4 people responded with 11 pairs of shoes. And then we're going to begin our analysis. So we'll go ahead and click that, begin analysis. And the first thing we have is a dot plot. We've done dot plots in school, So I think this is not too earth-shattering. So I'm just going to go ahead and copy this dot plot. You would be doing this by hand. I'm going to copy and paste it for you. So here's our dot plot. Copy and paste it in. Let's go back to stat plot and let's figure out what's the next plot that we can do. And I think the next plot that we are supposed to do is a stem plot. So let's make a stem plot. Okay, so should I split the stems? Well, let's take a look at it before we even talk about splitting the stems. 0 would be the tens place, and 2 would be the ones place. So if I look at it, this is chunked as 0, 2, 0, 2, 0, 3, 0, 4, 0, 4, 0, 5. So that means we have two people with 2 pairs of shoes, 1 person with 3 pairs of shoes, 2 people with 4 pairs of shoes, 2 people with 5 pairs of shoes. And then down over here, 2, 0 means that 1 person had 20 pairs of shoes. Now, this stem plot, the way it currently looks, it doesn't really give a lot of detail, mainly because we have 3 stems. 0, 1, and 2 are the stems. So what we're going to do to give ourselves a little bit more detail is we're going to split the stems, and you're going to see what happens when I split the stems. Yes, let's split the stems into 2 groups. Okay. We have split the stems, so we have 0, 2, 0, 3, 0, 4, and then 0, 5 starts on a new stem. So for each tens place digit, we've got 2 stems. And this is nice because, if you don't have huge variation of range, or a huge variation in the numbers, you can kind of expand the numbers to take a closer look. Let's see what happens if we split that into 5 groups. Okay. So we have 0, 2 and 0, 3 together, 0, 4 and 0, 5 together, 0, 6 and 0, 7, 0, 8 and 0, 9 together, all the zeros and ones together, 2s and 3s together, 4 and 5, 6 and 7, 8 and 9, 20 and 21. So I'm not sure which one of these is probably better. I'm going to go with this one. It's spread out a little bit more. It gives me a much nicer looking shape, in my opinion. But again, like I said, you should be able to create these by just by pencil and paper and with a list of numbers. So make sure you get used to doing that. I'll go ahead and copy and paste this for you. So here's our stem plot. Maybe make that a little bit bigger. Notice that over across the bottom it tells you exactly what's being measured, the number of pairs of shoes. And also, there's a key here. Make sure you put the key in your stem plots. 2/0 means 20. Without that key, it's kind of hard to know, because that 2/0, that could be 2.0 or maybe 200. I don't know. It really depends on how the numbers are formatted and what it says in the key. So the key is important. That's probably why it's called a key. Alright, we're going to go back to stat plot and do our third plot, which is a histogram. So the histogram here looks a lot like a bar chart, with visual differences being that the bars are kind of adjacent to each other. There's no space in between each bar. Each bar represents a range of values and the frequency of measurements in that range. So if I take a look at here, this first bar is between 0, including 0, and less than 5. And there were 5 measurements that were either 0, 1, 2, 3, or 4. The second bar over here, 5 to 10, that means it says that there were 10 measurements that were either 5, 6, 7, 8, or 9. Remember, strictly less than 10. I think you get the picture. Notice that we have the axes are again uniform, not skipping any numbers, not doing 1, 2, 7, 8, 12, 15, 20. It's a uniform scale. It's labeled with frequency and the number of pairs of shoes. Stat plot is nice because if you wanted to, you could change the interval width. Let's say I wanted to make the interval width 2, like we did for our histogram. No, what was that called? Our stem plot. This is looks a lot like our stem plot, but let's not do that. Let's make our interval width 5. That's pretty nice looking. That's a pretty nice looking graph. So let's go ahead and copy and paste that back into your homework StatMedic sheet. Some things to notice about the histogram versus the dot plot is the dot plot, it can be a very wide graph, whereas because you're grouping data with the histogram, that graph can get narrowed down a little bit. Splitting stems will allow you also to control the width, or in this case the height, of the stem plot, but a lot of people gravitate toward the histogram here because it is easy, it's very flexible on how you want to group things. As long as those interval widths are the same, you're going to be okay. One other thing that I didn't mention that I probably should is you will notice that the bars kind of begin and end at the interval endpoints. So the left endpoint of this is 0, so the bar starts at 0, and the right endpoint is 5, so the bar goes all the way to 5. Now we know that 5 isn't going to be part of that first bar. 5 is going to be part of that second bar, and that's a standard practice for most bar graphs, is to include the left endpoint, but exclude the right endpoint. So, and again, all the widths are uniform. Every bar has a width of 5. If you see a bar graph where the width are all different, chances are you're looking at a bad graph. There is a way to do it correctly, but that's actually something that we don't cover in AP Stats. You might want to look at that, the correct way to make a histogram if the interval widths are not all the same. So the next question, number 4, would be to describe the distribution. So this part of the question is really important. It's asked every year on the AP test. You have to describe a distribution, and you're always describing the same 4 things whenever you're asked to describe or compare distributions. Over here you have shape, outliers, center, and variability. Those 4 things you've got to have locked down in that memory because you will be asked that. So let's start by looking at shape. What are the different shapes? And a lot of people will argue that you can only see the shape from a histogram, but that's not true. You will notice on all 3 of these graphs, you can kind of see the same shape. Okay, for the stem plot, you might have to turn the stem plot sideways, but they all kind of have that same signature shape where the bars get very tall on the left side and very short on the right side. So let's take a look at the names of these distributions. So over here we have a symmetric distribution. Now this symmetric distribution is a very specific symmetric distribution. It would be with only one peak, but really anything that is symmetric, whether it's a U shape or if it's straight across like this one down here, those are all uniform. Uniform means the same shape all the way through. Okay, the left side looks like the right side. Actually, that's what I should say. The left side of the distribution looks just like the right side of the distribution. So this is symmetric and unimodal. That's a very important one for us. This one over here is skewed left. This third one is skewed right. Now, for most students, skew left and skew right is opposite of what you think it's going to be. So skew left means that there ain't nothing on the left side, but there's a lot on the right side. Okay? So the skew left means everything is on the right side of the distribution. Skew right is exactly the opposite. Everything is on the left side of the distribution. Okay? Uniform means that all the bars, every measurement is about the same. Okay, every measurement isn't about the same, but the count for each grouping of measurement is about the same. Okay, so uniform. Now this isn't perfectly uniform, much like this one over here isn't perfectly symmetric, but as long as it's close enough, you can call that uniform. So if you can see that straight line on all the bars are about the same height. That's a uniform distribution. The next one we have here is a bimodal distribution. In a bimodal distribution, there are two distinct peaks. I'm going to say that again. Distinct. Okay? There has to be some distance between them, and they have to be distinct, really look like two different peaks. Okay? If there's more than two peaks, we would say multimodal. Okay? So we have symmetric. Another thing would be unimodal. If I take a look at skew left, that's actually skewed left and unimodal because there's only one peak. The third one, skewed right, and this is actually could be described as skew right and unimodal because again there's only one peak. Uniform. Okay, so someone might be looking at this and saying, well, that's 1, 2, 3, 4, 5, maybe 6 peaks, and that's not correct. Okay, these peaks are not distinct. There is not enough distance between them, and there is not a huge difference here in the middle or between those two peaks. So that's I'd have a hard time saying that this is a multimodal distribution. Uniform would be better here. Bimodal, two distinct peaks. Multimodal, many distinct peaks, more than two distinct peaks. And I got to tell you, here in AP Stats, we're not going to do a whole lot with these last two. We're going to be mainly concerned with these first four: symmetric, unimodal, skew left, skew right, uniform, and to a lesser degree, bimodal. Looking back at our graph, this looks like we have a lot of measurements, a lot of people with a low number of shoes, not a lot of people with a high number of shoes. So all of our measurements are on the left side. So we would say that this is a right skewed distribution. In fact, we could say right skewed unimodal. How about for those outliers? Well, an outlier is any measurement that is significantly different than the others. Those are usually well seen on a dot plot. You can sometimes see it on a histogram if it's really distinct. But you might be tempted 16, 18, and 20. Maybe those are actual outliers. We don't know. If I take a look at the histogram, I don't see anything on the histogram that looks terribly off. This bar is not this bar from 20 to 25. This isn't much different than this bar over here from 15 to 20. So I would be hesitant to say that there are any outliers. And if you're saying for area, that's just a judgment call, you're right. It's just a judgment call right now. Later on, we're going to get some very specific tools to judge whether or not we have an outlier or not. But for right now, we're just going to say if it looks like an outlier, it probably is an outlier. So here, you could probably make an argument for 20, maybe 18, probably not 16. But because my histogram doesn't show them, I'm going to say that there are no outliers. In a minute, we're going to learn some very specific, okay, maybe not in a minute, but at some point we're going to learn some very specific measurements for the center of a distribution. You probably know some of them. And if you've already calculated a mean or a median, then you basically know everything I'm going to teach you on that. We're not going to compute a mean or a median here. We're just going to kind of eyeball. So based on this distribution, it looks like maybe 7 is the center of this distribution. Where would it be here? Yeah, maybe 7. Actually, looking here, maybe 8. So 7 or 8. If you know how to find the median or the mean, you might want to go ahead and do that now. I'm just going to say about 7. And finally, we have a measure of variability. So variability gets measured in one of 3 ways, really. We can find you can find a standard deviation. We can find what's called an interquartile range, or we could find what's known as the range. Right now, we're just going to use the range. So the range of this would be the minimum minus the maximum. So the maximum is 20, the minimum is 2, so 20 minus 2 is 18. So we're going to say the range is 18. So that's one way to quantify variability. Now I got to tell you, that's actually the least preferred way to calculate variability. I would much prefer you use a standard deviation or an IQR, but as of right now, we don't know how to compute those things, so we're not going to worry about that. Okay. Which of the 3 types of displays do you prefer and why? Well, that's really up to you. I can tell you the way I feel about it. I feel like the histogram is probably a better way of going, but again, this is your choice. Okay, so what have we learned so far? We have right skew, unimodal. Remember the different shapes that we have. Symmetric, unimodal, or symmetric, left skew, right skew, uniform, and then the modal stuff. We have unimodal, bimodal, and multimodal. Outliers are any of the measurements significantly too big or significantly too small, or much larger than the rest of them or much smaller than the rest of them. I didn't find any evidence of that. Center, that's mean or median, and variability, that is IQR or standard deviation, or if you have no way of doing anything else, doing the range. Now we're going to take a look, and for number 6, how do the number of pairs of shoes for females and males compare? Let's start by separating the data, which I did over here. We've got that data separated. And then now we're going to enter this data into Staplet.com. Make sure to make 2 groups. So let's go to Staplet.com. And we're going to go back to 2 groups. So I'm going to start all over again. And I'm going to choose, as soon as the web page loads up, I'm going to choose quantitative variables, multiple groups. So we have 2 groups. Okay, the first group we're going to do is the females. And let's copy and paste their numbers. There we go. Second group is males. And we're going to copy and paste their numbers. There we go. And we only have the 2 groups, so we're good to go. Begin analysis. So we've got first group here is our dot plots. Notice the dot plots are stacked on top of each other, and 2 is over 2, 12 is over 12, 20 is over 12. Each horizontal axis is labeled females and males. So we get a good idea about comparing these two. So I think we have to copy and paste this one over to the StatMedic. So let's copy and paste that. Now I hate distorting the image the way I've done here. I've kind of exaggerated it vertically, but I think that's the only way I can get these to fit nicely. So there's our side-by-side stem plot. And something that I noticed over here is I forgot that they actually told you the mean, median, standard deviation. So if you're doing this at home, you could probably go back to the previous data and go ahead and enter in that mean and standard deviation. In fact, I'm going to go backwards and do that right now. So here we are back with the data of the group data, and what am I seeing here? I'm seeing a mean of 8.7. That certainly stands, that's good for the center. I see a median of 7.5. So I'm going to put both of those in to my StatMedic paper. So here we go with a mean of 8.77 and a median of 7.5. The next one we could do is a variability. I'm going to keep the range there because the range is actually 18, but let's take a look at what StatPlot told us for the other ones. Now StatPlot tells us that the standard deviation, SD, is 4.75. So we can go ahead and put that in there. I don't see IQR here, and to calculate IQR is Q3 minus Q1. So it's going to be 12 minus 5. I mean, you don't even know what Q3 and Q1 is, so it's kind of weird for me to be telling you how to do this. But IQR is 12 minus 5, which is 7. So I'm going to go ahead and put that in our chart. So this looks a lot better. We've got numerical values for the center and the variability. Those are generally the only two things that we have that we use numerical values. You might ask, for area, do I need to do both the mean and the median? And the answer is no, you don't have to do both the mean and the median. One or the other is sufficient. We're going to talk about when one is more appropriate than the other. Same thing with variability. You don't need to leave all three of them, but maybe as we're learning statistics, it's a good idea to get used to calculating all three of those, even though you're not really calculating standard deviation. We're going to go back to where we left off here. Oh yeah, we were supposed to do the side-by-side stem plots. So let's go back to the previous data, and we'll try to get those side-by-side stem plots. So I've changed the graph type to stem plot, and you'll notice that this is a very strange looking stem plot. We've got females going to the left and males going to the right. You could have separated them out, but this is the way that most people prefer so that you can compare the distributions. Now, because we did it before, we're going to split our stems again, but this time we're only going to split it into two groups. That's going to be a little better. And wow, take a look. There's a really big difference in these two groups now. Notice how the males are definitely concentrated in smaller values, smaller numbers of pairs of shoes, while the females are slightly higher number of pairs of shoes. No female owned less than 5 pairs of shoes. So the female distribution is definitely centered higher than the male. Let's go ahead and copy and paste that to the other one, to the StatMedic. You read these pretty much the exact same way you did for the regular stem plots with only one group. But when you have two groups, again, the one group is going out to the right of the stems, the other group is going out to the left of the stems. So there's our side-by-side stem plots. And then the last one that we're going to do is the histograms. So let's change the graph type to histograms. And we'll see. Oh, okay. Well, this is kind of strange, I guess. With the histograms, all you could really do is put two histograms on top of each other. So side-by-side histograms. It's kind of a lot like the way we did dot plots. Those were side-by-side as well. But I don't think there's a whole lot to say here. We already talked about this. The female group is definitely centered a lot higher than the male group. And we can see that because the female distribution is shifted to the right, whereas the male distribution is shifted to the left. So let's copy and paste that over. There we go. We've got all three of our graphs together again. I can't stress this enough. You will have to draw these graphs without the aid of something like StatPlot. You will have to do these by hand at some point. So get used to creating these histograms. Let's see. Compare the distributions of shoes for the number of shoes. Be sure to address shape, outliers, center, and variability. That's SOCV. So let's go ahead and do that. I'm going to write the word shape just as kind of a reminder to me that this is what I'm comparing. And how do the shapes look? Well, to me, they both look right skewed. Okay? No. Yeah, right skewed distributions. So, both distributions are right skewed. As we're comparing the distributions here, you do need to write sentences, and you need to make sure that your sentences are comparative sentences. Which one is bigger, which one is smaller, or which one's smaller, or are they both the same? Outliers. Now in this case, I've taken a look at the female ones. There doesn't seem to be any outliers. But here with the males, this looks like this might be an outlier, 18. It's really well seen in the dot plot that 18 is so far away than the rest of the males. So the females do not have an outlier, while the males have one high outlier. High meaning greater than, the measurement is greater than the rest of them. And that high outlier was 18. I'll put that in parentheses. Okay. The next thing that we're supposed to compare is the center. Oop. Weirdness. Center. Okay, so let's go back to our stat plot and take a look at the center measurements. Okay, the measurements of center, the females have a mean of 10 and a median of 11, while the males have a mean of 6 and a median of 4.5. So it looks like the mean number of shoes is greater for females than it is for males. And we're going to leave a measurement to concrete that, or to support that. So the number of shoes, number of pairs of shoes. So here we see that the number of pairs owned by females is generally greater than the number of pairs owned by males. For measuring the means for males for females is 10.24 versus 6.25, and for median it's 11 versus 4.5. Okay, so that's for center. Notice I didn't use the word center in my explanation of center, because center is a description. It's not technically a statistical vocabulary. So that's just something that'll help us memorize things. So what about the last one, which is variability? Well, let's take a look at our measurements. Females' standard deviation is 3.99, while the male standard deviation is 5.33. So there's greater variability in the number of shoes owned by males according to standard deviation. What about, does that hold true for their IQRs? Well, the IQR for females is 12 minus 6.5, which I believe is 5.5. And then for males, the IQR is 8 minus 2.5, which is what, 5.5 as well? So those are really close. So if I want to make the case that females have or males have a greater variability in the number of shoes they own, I would probably stick to using the standard deviation. So weird things that are happening here, right? The standard deviation seems to have been greatly affected by something, and that something you might guess would be that outlier measurement of 18, and you would be correct. That outlier definitely does something to the mean and the standard deviation, but we'll talk more about that later. Right now, we'll just go ahead and compare these two measurements of variability. So in looking at standard deviation, the males have more variability in the number of pairs of shoes they own, 5.43 versus 3.99. However, in looking at IQR, males and females have about the same variation in the number of shoes they're owned, 5.5. So we're making a direct comparison. We're using comparison words, have more, has less, greater than, less than, and we're leaving numbers and statistics to justify our conclusions here. So I know that's a lot of things. It definitely is. So let's go ahead and take a look at what are the important ideas that we were supposed to learn from this. Well, the first thing that I have here is this idea of shape, and the different shapes that we were looking at were symmetric, left skew, right skew, unimodal, bimodal, and multimodal, and I forgot uniform, so let's put uniform here. The next thing that we're going to look at, when describing distributions, we need to go back to that acronym SOCV, shape, outliers, center, and variability. We've got center, that is going to be mean or median. We've got variability, that's going to be standard deviation or IQR, Q3 minus Q1, or range, and range is max minus min. So we have all three of those things, and don't forget to compare. Use comparison words. Use comparison words when comparing, and always, always, always use context. If the numbers are about shoes, then you should be writing about shoes. Always, always, always use context. Okay? That's all of the stuff that we're going to be looking at today. It's a lot, but I feel like it's pretty easy, and I know you guys, I know a lot of you anyways, you guys have this, and I will see you all on Monday.